let me try this. I'm going to talk about this glass curtain wall system. How I kind of come up with that and design it. So let's take a look. This is one system. Well, it's the same system. This is the 6330 project, and you can see how we've got a glass corner here. It's totally transparent. This thing floats. It actually hangs from the structure above. On the side, it's attached to the side of the wall, so it hangs and floats off the side of the wall there too. So let's see how some calculations and details and stuff, how to put it together. Alright, so this curtain wall system is it's not a universal system. It's got to be custom designed for every application and every site to respond to wind loads and all of the odd conditions you'll get when shaping the glass in the corners and everything else. So basically the same as this curtain wall system I did at the Ruskin house. It's a Cypress and glass, and this one happened to have some 18-foot verticals that needed these stainless steel braces on them. So in this rendering here, you can see the layout of the spaces. It's kind of diagrammed with the masonry with the shell. It's split by a north-south bar of private spaces, and then on the east you have the living spaces. So then you see, once you add the curtain wall system, it just sort of meanders through there and almost sort of goes where it wants to. It sort of dances through the kind of shell system. So we start out with a wind load map from the ASCE7. Then we move into a series of calculations that are specified in the ASCE7. This is a 2002 version as opposed to the 2010. And then we use that to determine the wind pressures, the design wind pressures on all the different parts of the building, and we can apply it to glass, the main wind force resisting system, the block. And then we take those values and we use them to calculate the bending stress in all the beams for different parts of the building, whether it's a concrete beam or wood beam or even a piece of glass. So you see, we break it down into just to the very basic elemental pieces, and that is, we just need to know how to find the wind load, the loading on it, dead load, live load, wind load, and then we just need to know how to size a member, whether it's wood, steel, glass, concrete, plastic, whatever it is, determine a size for the piece of material that we're going to use to support the load. And that's it. And load transfers from the reactions of one piece and it becomes a load on the next piece. So we just have to get a load path that goes down to the foundation. And then we're free to do anything we really want to. So now we can design, really design a curtain wall system, a glass system, a door, anything really. It's elemental, that's what it is. So you can see, with that as the basis for designing all the pieces, we can do things like design this piece of curtain wall that hangs from above and is supported and cantilevered off of a stair frame. In this case, we have the lower edge supported by the concrete floor, the top edge is embedded in the ceiling and supported by that. The jamb here is embedded in the concrete block wall, and you end up with a very simple, thin system here that really does what it's supposed to do, and that's recede. With that as the basis also, we can do overhead glass systems because we've broken it down now into a set of load conditions, define the set of load conditions, and then design the members that support it based on those loads. So now it doesn't matter if we're using steel, like these frames are here, or a combination of steel and cypress. And in this case, we have there's one condition at the edge that has a steel tensile rib underneath it. So then this was fabricated. You probably using CNC technology here. We're cutting all the pieces. Some of them are tapered. And we also using a flat bar. It's the most cost-effective way to do it, and I can get any shape and any angle. I can get a Z section to get this overhead glazing system to both meet the code and do what the original vision and intent was, and that's to sort of remain low profile and as much as possible sort of disappear above your head, and just give you the idea that it's sort of floating above this above the space in this Cypress frame. So also taking that idea of the sort of elemental method of thinking about this in terms of defining a load and then sizing and calculating sizes for the members, no matter what they are, you're sort of unlimited in what you can do. I just did another project. It's just a little curtain wall system for an enclosure, but it's impact resistant glass, and for that I just use a plugin called Scan and Solve. First I run calculations that I actually set up in Grasshopper, a plugin for Rhino also, and generate the impact load based on formulas, physics formulas for determining impact factors for loads, and then we just put the load in and design it by the same methods, and so you really see how sort of unlimited the possibilities of design are, and you can really make something that really says what your sort of original vision is. So this just shows the scan and solve process and sort of generating the report and the internal stresses for the members. But you really see how sort of unlimited the possibilities are, and probably need to do another video, hopefully soon, of that the curtain wall at the Ruskin house that I mentioned earlier in this video. So that was an interesting project to do in terms of spanning and using tensile members to take additional wind loads because of the spans and everything. But it really opens up possibilities as far as design. And remember, this is not just about the glass walls. The entire structure is designed the same way. So really the options are pretty much limitless. Elemental.